as long as you love me.
Okay.
Hello, my name is Giovanni,
I'm Brian.
and Geometry Project. Sorry for the wind. It's cold outside.
Yeah.
Alright, so what I'm gonna be talking about is postulate 3. Pos 3-1 corresponding angles. Corresponding angles are when two lines are crossed by another line called the transversal. The angles in matching corners are called corresponding angles. I'll do an example. Alright, in this example, these are the corresponding angles. A is congruent to E. They're congruent. B is congruent to F. C is congruent to G. And D is congruent to H. So yeah, it's pretty obvious. Like, it's really simple. Math, not really that hard. Alright, another lesson I'm gonna teach you guys is alternate interior angles theorem. Alternate interior angles. Pretty much of a, it's cold out here. Alternate interior angles when two lines are crossed by another line, called the transversal. The pairs of angles on opposite sides of a transversal, but inside the two lines, are called alternate interior angles. I'm gonna show you an example. Quite similar to the one we did before. Alright, in this example, these are the alternate interior angles. C and F are alternate interior angles. C and F. D and E are also alternate interior angles. E. To help you remember, the angle pairs are on alternate sides of the transversal, and they are on the interior of the two crossed lines. Alright, now I'll be talking about interior angles of a transversal. Transversal. Created where a transversal crosses two, usually parallel lines. Each pair of interior angles are inside the parallel lines and on the same side of the transversal. I'm going to show you an example. Key. Sorry about the wind. Alright, notice that the two interior angles shown are supplementary. These angles, 70 degrees, 110 degrees. Add to 180 if the lines PQ and RS are parallel. There you go. Alright, now I'll be talking about alternate exterior angles. Sorry about the wind, it's really crazy out here. Okay. When two lines are crossed by another line called the transversal. The pairs of angles on opposite sides of the transversal but outside the two lines are called alternate exterior angles. I'm gonna show you an example. What? I know. Alright. In this example, my bad. Gotta put the letters. Alright, in this example, A and H are alternate exterior angles. A and H. B and G are alternate exterior angles. And G. To help you remember, the angle pairs are on alternate sides of the transversal, but they are on the exterior of the two cross lines.
My name is Brian, and I'll be explaining alternate interior angle theorem. So, alright, so the alternate interior angle theorems is when two parallel lines are cut by a transversal, and the resulting alternate interior angles are congruent. So let me show you like an example. So right here in this figure, if I forgot to put this. Sorry. If parallel KL is congruent, then angle 2 and angle 8 will also be congruent, and 3 and 5. So how I will explain this will be, since parallel KL by the corresponding angle postulate, which right here will be angle 1 and angle 5, then by the definition of congruent angles, M angle 1 will be equal to M angle 5, and since angle 1 and angle 2 form a linear pair, they are supplementary. So m angle 1 plus m angle 2 will equal 180. And also angle 5 and angle 8 are also supplementary. So it will be m angle 5 plus m angle 8 equaling to 180. And if you substitute m angle 1 to m angle 5, then it will be m angle 1 plus m angle 8, and it will still equal to 180. And if you subtract and subtracting m angle 1 from both sides, we will have m angle 8 equaling to 180 minus m angle 1 equaling to m angle 2. So then it will be angle 2 equals to, well, congruent to 8. So you can now prove that angle 3 is congruent to angle 5 using this same method. So yeah, you could prove that these two are going to be congruent and these two will be congruent. So hello again. We're gonna go over theorem 3.6, converse of the same side interior angle theorem. So same side interior angle theorem. So if a transversal intersects two parallel lines, then the interior angles on the same side of the transversal are supplementary. So I'm gonna show you an example right here. Just draw this out real quick. Yeah. Alright, so as you can see here, this angle right here is angle 51 and this is angle 129. So this all has to equal 180 from this line IL. So IL has to equal 180. So what you do is, if you see these right here, you could just like add them both. So 51 plus 129 will be 180, and you can prove that by subtracting 180 to maybe 51 or 129, your choice. So yeah, take it out from here. 10. 9, 2 and 1, and there you go. There's the correction. Hello, so we're gonna go over theorem 37, converse of the alternate exterior angle theorem. So like I said, alternate exterior angle theorem. So the alternate exterior angles theorem is when two parallel lines are cut by a transversal, then resulting into the alternate exterior angles are congruent. So let me show you like an example here. Let's show you as lines. Yeah, this came out a little bit crappy. 1, 2, 3. Okay, anyways. So here in this figure, 1 and 7 are congruent. So 1 is congruent to angle 7. And 4 and 6 are also congruent. So to prove this, it will be since angle L, angle, yeah, L and K, right here, T. If angle L and K, by the corresponding angle postulate, it will be angle 1 is congruent to angle 5. So, and also by the vertical angles theorem, angle 5 and angle 7 will also be congruent. Then by the transversal property of congruence, angle 1 will be congruent to angle 7. So now you can prove that angle 4 and angle 6 are congruent using the same method. So the converse of this theorem is also true. That is, if two lines K and L are cut by a transversal so that the alternate exterior angles are congruent, then KL. So yeah. Hello again. Now we're gonna go through some vocab. Transversal. I think it's right. No, okay. Meaning a line that intersects two coplanar lines at two distinct points. So in basic, it would actually be how can I say it? Like a line that just like, for example, can I explain it real quick? A line that just like cuts between two lines. So right here, as you see, this whole thing right here will be a transversal. So it will be kind of like for example, just ignore this. It will be like P and Q. And moving on, just like another reminder of the whole alternate interior angles. Angle 1 and angle 2 are again alternate interior angles. So, quick example. Yeah, make it small. So like 1, 3, 2, and 4 1 will be in 2. And moving on will be, let's see. So now I'm going to review again 2 other ones. This one will be the same side interior angles. So angle 1 and angle 4 are same side interior angles. So here's the transversal, I guess, between these two. One, three, four, 2. So since this be same side interior angles, it will be 1 and again 4. So
What are those called again?
Huh?
What is that called?
this here,
Yeah.
same side interior angles. This right here is shown.
Alright.
So sorry about this. Sorry, here's another one. Angle 1 and angle 7 are corresponding angles. So as you can see, here's the transversal. Four, 2. Alright, corresponding angles 1 and 7, 1, 7 are going to be corresponding angles. And yeah, now off to 2 triangles. So this right here, sorry, this triangle here is gonna be an equilateral, well, equiangular. Equiangular triangle, which means all angles are gonna be congruent. So an acute triangle will be all angles are acute, meaning they're all lower than 90 degrees. So we all know about the right triangle, which means only one angle is 90 degrees. So yeah, then there's the obtuse. There's the obtuse angle, which is one obtuse angle. Then here you go. Here's the equiangular triangle. Equilateral. Equilateral triangle, meaning all sides are congruent. See how up here, the equiangular is all angles are congruent, but right here it's all sides. So next off to an isosceles. Which is at least two sides are congruent. And next up, and the only triangle that does not have any of these from above is a triangle called a scalene. Scalene, which has no sides congruent, So no sides, no sides, no sides congruent. It's loner. Yeah. The final countdown.